So most engineering teams say they use caching in their LLM system, but that phrase is doing a lot of hiding. Because caching in an LLM system isn't just one thing. It can mean like 5 or 6 completely different mechanism, each one trying to eliminate one expensive operation within the stack. Now, if you don't know what layer you're optimizing, you can spend a real engineering time building a cache that does not even move a needle. Today, I want to break this down the way I wish someone would have helped me when I was building my first RAG application, which was like 2.5 years before. But in this video, I'm going to cover layer by layer what each cache does and where to start. Now, before we get into this video, quick introduction about myself. My name is Mahesh and I've been building AI based applications for almost 2.5 years, and hopefully some of these videos help someone who's just getting started.
So here is the mental model what I use, and once you have it, everything else clicks. What repeated work am I trying to eliminate? Now, once you ask this question, it may seem a little obvious, but it immediately clarifies that there are four types of repeated work you may want to eliminate, especially in an LLM based system. The first one is repeated response generation. So, in this case, you are calling an LLM for the exact same question, and it could be exactly same or it could be semantically same. The second one is repeated retrieval. So in this case, you are invoking a vector database with a query which you already ran. The next one is repeated tool calls generation. In this case, you are calling an external API or a database which you already performed in that session. Now, the last one is repeated prompt prefix computation. So, in this case, you're sending your long system prompt and paying for it every time. Now, four different types of repeated work, and you can build four different types of caching. In a well architected framework, you don't just pick one, you kind of layer them all together. Now let's look at the first layer of caching. Now this one sits right at your front door. Now I'm going to break this into two different parts because they solve a slightly different problem. Now the first one being the exact question match. Now in this case, if you are asking the same question again, there is no need to go to the LLM to get the response. You can always return the response from the cache. Now the important thing to understand is your system prompt should not change, your model configuration should not change. If you ensure that that remains the same, then you can return the response from the cache itself. Okay, it's very easy. Now, how would you build it in a cache? In this case, let's say you're using Redis as the cache database. You can use the question as the key and the response as the value. And you have to put that guard that your system prompt does not change, your model configuration should not change. So the question matches, the system prompt matches, return the cache response, skip the retrieval, skip the LLM entirely. Exact question caching is great, but there's an obvious limitation to it. Users rarely ask the same exact or type the same exact sentence twice. They may ask a question like, what is an LLM? 10 minutes later, they may ask, like, what is a large language model? So in both the cases, the intent of the question is same. But since the text does not match, the exact question cache is going to miss this. Now this is where semantic caching comes in. The semantic caching, the way it works is, it does not match the exact text, but it matches the meaning of the text. So how does it look under the hood? Now, first of all, for semantic caching, you need a vector database. And let's say, as an example, you get a question like, what is an LLM? So you would embed that question and you would store three things inside the vector database: the embedded question, the original question, and the original response. Now, let's say 10 minutes later, you get a question like, what is a large language model? So in that case, you would embed that question and do a similarity search against a vector database. So you'd get a match and a score. Now, if the score is 0.94, which is pretty close, then you just return the response instead of routing it to the LLM. And that's how semantic caching works. Now you may want to like fine tune and experiment a little bit on the threshold. If it is too high, like 0.99 or something like that, then you are just trying to mimic the exact question cache, which you don't want it to be. If the number is too low, let's say 0.75, you'll end up serving an answer from the cache to a question which meant differently. So in both the cases, you don't want that to happen. So fine tuning and experimenting is something what you want to do when it comes to semantic caching. The last but not least, your system prompt version should not change. Your model version should not change. Now, these are something which we discussed with the exact question type matching, and that still applies to semantic caching. Now, let's look at provider level prompt caching. So here's the cache most of the application developers don't think about because this does not belong to their code. It belongs to the model providers like Google or Anthropic or OpenAI. So in this, if your system prompt does not change with every request, the model providers have the ability to recognize these repeated prefix and reuse the cached computation instead of regenerating the input tokens with every request. Now, this is big and this is like absolutely free. This directly translates into token economy and faster time to first tokens. But here is the downside. If you tend to insert dynamic content on the top, you lose the benefit of this cache. So the discipline is very simple. It's structural more than anything. Put your static content on the top, dynamic content can go lower. If you just follow the simple thing, your application just becomes directly compatible with provider level prompt caching. And as I said, this is like absolutely free of cost. Let's look at tool call caching. Now, if you're building agents, this one is simple to understand and surprisingly often overlooked. Agents make tool calls. Now, this can be your weather API call or user profile read or knowledge base lookup. Sometimes in a reasoning loop, agents can make the same tool calls with the same input parameters multiple times. And that's like a wasted latency and wasted API calls. And why would you want to do that? So instead of that, build a cache with the key being the name of the tool and the input parameters, and the value can be the response of the tool. Now, if the agent is invoking the same tool again with the same input parameters, then you can return the response from the cache instead of making a fresh call. The rule is very simple. Build a cache which is read-only deterministic types like weather APIs, user profile reads, knowledge base lookups with a shorter time to live. You don't want to build a cache with for a side effecting tools. You do not want an order place result served through a cache when a user is trying to place a new order. Now let's look at retrieval caching. Retrieval caching is something you want to build if you want to skip the vector database completely and use a cache instead. So you will store the question as the key and the chunk IDs as the values in that cache. For this to work, your questions has to be exact match. Otherwise, this is not going to work. Now, I would say that this is something which is redundant because our front door caching is already catching the exact question types as well as the semantic question types. Secondly, if you're thinking about the cost of embeddings plus the speed of vector database, I would say that vector database are pretty fast. You're talking about 10 milliseconds to 100 milliseconds. Also, the cost of embeddings is pretty cheap. You're talking about like millions of queries for pennies, right? So considering these two scenarios, and if you're implementing a front door caching, retrieval caching is completely redundant. So I would just skip this. So let me pull all of this together. If you're standing up a new system today and if you're wondering where to invest first, this is how I would sequence this. I would start with the front door caching because that covers your exact question types and your semantic questions. And of course, that skips the LLM completely. So rich dividends. The second one, I would say that stabilize your prompt prefix. So provider level caching works in your favor. And this is like a structural discipline you want to have, and it's absolutely free of cost. The third one is tool call caching for any agent making repeated calls, external reads in a session. Easy to implement, clear ROI, and your agents will thank you. And that's how I will sequence this. So the through line is very simple. Every cache should try and eliminate a specific expensive repeated operation. And if you can't name what expensive operation it's trying to eliminate, it's probably not worth building. Also, if you're building production AI system and found this video useful, please subscribe to this channel. I post weekly on AI stuff, AI architectural patterns like this, and thanks for watching.